This is the first question that we are going to take a look at in this series. So this is the two-sum problem, and it's a very common problem that's always been tested in technical interviews. So let's take a look at it. So given an array of integers, which is called nums, and an integer called target, we are supposed to return the indices of the two numbers such that they add up to target, right? We can also assume that each input would have exactly one solution and that we do not use the same element twice. We can't use the same element twice. And we are able to return the answer in any order, right? So this is the main problem statement. So a quick summary is that the input that we are given is 2, which is one is an array of integers called nums, another is the integer called target. And our output will actually return two numbers, and each of the number is actually a reference to the index. So in this case, when we are given nums equals to this array and a target of 9, we output 0 and 1. And if you take a look at this, we can see that 2 plus 7 equals to 9, and those reflect the corresponding indexes of these two numbers. So that's the output that we get, 0 and 1. Similarly, in the second example, we can see that with the target of 6, we're returning 1 and 2, and checking at index 1 and index 2, we have 2 and 4, which gives us a sum of 6. So we can go on to the third example, which is 3 and 3, and target is 6. We have exactly one solution, which is 0 and 1, both numbers. And again, the question I've already said, there's always going to be exactly one solution. So we do not need to worry about cases where we do not have a solution. So a couple of ways that we can actually approach this. Now that we understand the problem, so let's think of the brute force approach first. So in the brute force approach, what we are going to do is we are going to loop through the nums array twice, right? So there's going to be two for loops, two nested for loops, and we are going to actually go through each element and find another element that when combined, when the sum is equivalent to the target, we are going to return the indices. But that kind of approach will be giving us a time complexity of O(n) square, right? So that is not a good time complexity to achieve for, especially in a technical interview. O(n) square is considered pretty slow. It's quadratic time complexity, and let's try to do better, right? So in this case, what we can do is to actually think about the data structures that we know. What are the data structures that we know that can help us with this question? So very simply, we need to keep track of elements, and when we are passing through, when we are looping through this array, this list in Python, what we need to do is we need to see if there is a previous match to this element that we have seen before, and we need to aim to do it in a faster time complexity than O(n) square. So let's try to aim and do this in just one single for loop, right? So that would be something like this. So let's say we need to keep track of the elements that we have seen. So we will create a num map. So this is nothing but a hash map in Python. So in Python it's called the dictionary, right? So now I'm going to loop through this nums array. So let's say it's like a for loop here. So for I in range, the length of nums, and let's say we need a complement, right? What we are going to expect is target minus the current number that we are seeing. So what we're basically trying to do is to see that if we have seen the complement before. So if the complement is in the num map that we created, that means we already know that, hey, there is actually a match that we have seen before. So we can just simply return the current index, and nummap would be storing the link between the number and its index. So let's look up the index. So again, nummap is actually a dictionary mapping from a number to its index, okay? And we will be returning this. But if we don't find a complement in the hash map that we created, we are going to add this number there. So this number that we saw, the current so the current number that we saw, which is nums I, we will create a key and we will store the value as the index. I know there is no case where there's no solution, but if there are cases where there's no solution, let's assume we will return an empty array. So let's run through the code one more time and see if it makes sense. First, we're creating a dictionary, and this dictionary maps a number to its index as seen in the nums list, right? So let's go through each number in the list. So we have a for loop here. The first thing where we say, hey, I have got this number A, but what is the number I'm looking for? So the complement, right? What are we looking for is the target minus the current number. So this is the number that we're looking for. And nummap always stores what we have previously seen. So if this complementary number exists in this hash map, then we already know that, hey, we have already found the previous matching pair before. So we are just simply going to return the current index and the index that of the complement number. If we don't find that complement in this map, that means we didn't find a match for this. So instead we are just going to add the current number into the hash map, and we are going to map it to the index. So now let's try running our code. Hopefully there's no mistakes. And that's it, it's accepted. And because the order of these elements doesn't matter, so these two are actually equivalent, right? So the indexes that we are returning can be 0, 1 or 1, 0, but they still refer to the same elements that we have actually returned, right? So let's analyze the code once more. So we have one for loop here. So this means that this is actually running through each element in this nums1. Then that means the time complexity that we have achieved is O(n). So the time complexity is O(n), and where n refers to the number of elements in nums, right? So we have also used some space here, so there is going to be some space complexity, and we can approximate this to n, because again n here refers to the same thing, where n refers to the number of elements in nums. So in the worst case, we might be adding almost all of the numbers that we see in nums into this hash map. So this requires a space because it needs to keep track of elements, so that requires O(n) space. So compared to a brute force solution with two for loops, we have actually managed to achieve it in a single for loop, which gave us O(n) time complexity. A linear time complexity is much better than a quadratic time complexity, of course, and that's great, right? So what I've also done is that if you go to my website called writefrombasics.com, and if you go into this coding questions section, on the first post that you see is actually called toSum. I've listed all the different descriptions that I've gone through so far, including the two methods that I described. One is the brute force method, one is the hashing method, which we just used. So there can be some modifications to this question. So for example, if the question is just asking us to return the possibility if a particular sum can be formed from the array, and given that the array is already sorted, then we can actually use the two-pointer method. So what we're going to do is we are going to start with two pointers I and j at the start and at the end of the array respectively. So while I is less than j, in this while loop, what we are going to do is to check if the numbers at the two indices add up to the number sum. And if the result is less than the required sum, we increment I, and if the result is more than the required sum, we are going to decrement j. So if it's equal, that means we have found a pair that's equivalent to the target number, and we return true. So again, this is going to be a very linear approach, so this would give us a time complexity of O(n). The second method that we can use is to use something called binary search. So binary search is a way to search in a sorted array for numbers. So each time what it does is to reduce the search area by half. And if you're interested, if you can go to the interview prep section, what you can do is to actually go for this searching and you can go under the binary search to understand how this works. The only issue here is that the overall time complexity for the method becomes O(n) log n, which is going to be more than this method or this hashing that method that we have just talked about. So those are the different variations for this problem. Otherwise, it's a very straightforward using a hash table or a dictionary, as we call in Python. And the main trade-off between this and this brute force approach is that we are trading off space for time, right? We are trying to reduce the time complexity from a quadratic time to a linear time, and we are trying to actually do that by increasing the space we use. So in the brute force approach, we are using absolutely no additional space, no hash maps, no other data structures here. But here we have a hash map, and that increases space complexity. So that's it. So that's it for the two-sum problem. So give it a try after you understand the problem and the solution that I just went through, and I'll see you guys in the next video.